Alright, so let's do a quick review. Ohm's law. Guys, quit talking. So I like remembering Ohm's law as VIR. V equals I R. It's technically written as current is equal to voltage over resistance, but I like remembering it as voltage equals I times R. So voltage is equal to current times resistance. So let's do a few examples. So if 0.5 amps of current is flowing through a circuit, that has a resistance, be quick, of 100 ohms. What? Guys, quit talking. What is the voltage being applied to the circuit? So if 0.5 amps or half an amp of current is flowing through a circuit that has a resistance of 100 ohms, what is the voltage being applied to the circuit? So we begin with our triangle. Voltage is equal to current times resistance. We're solving for resistance. No, we're not. We're solving for voltage. So voltage is equal to current over resistance. Caden, stop clicking your thumb or shaking it. Voltage is equal to current times resistance. So this is our current. Current is represented with the letter I. In French, it's called current intensity, and it comes from the French name. They do intensity first, so I comes first. So 0.5 amps, and this will be the resistance. Stop tapping, please. So 100 ohms, we multiply them together, and we get 50 volts. Where'd the 100 go? If a lamp bulb has 20 ohms of resistance, and connected to 60 volts, how much current is going through the light bulb? So voltage is equal to current times resistance. So current is voltage over resistance. This is, yes? Yes. So voltage is 60 volts. Resistance is 20 ohms. That gives us 3 amps. If you measure the current of a circuit to be 1/4 of an amp, or 0.25 amps, and is connected to a 6-volt battery, what is the resistance of the circuit? Again, we apply for a triangle, voltage equals stop. So we're solving for resistance, voltage over current. So our voltage is 6 volts, our current is 0.25 amps, so 6 volts divided by 0.25 amps, and that gives us 24 ohms. So just like what we did for other units, we can have a meter, or we can use the letter M. We could write the word seconds, or we can use the letter S. We can write the word joules, or use a capital J. We can write the word volts, or use a capital V. We can write the word amps, capital A. We can use the word ohms, or write the Greek letter omega, capital omega. You can write the word or the letter. It's a more loopy W. That's capital omega, that's lowercase omega, if I remember my Greek right. Alan, put your mask on. Any questions? If you cannot write this symbol neatly, I will admit I can probably not the best writer of the Greek letter omega myself. Write the word ohms out instead. If you're unable to use capital letter A, write the word out, amps. Believe it or not, y'all have a problem with capitalization. I don't know how many times I see lowercase j for joules. I don't know how many times I see a capital M for mass. Or people put capital A for acceleration. That's not right. That's amps. If you wanted to be more precise, you could write amperes, which is French, but is the proper full name. We usually reduce that word down to just amps. It's not on the homework, but usually amps is very small, and we use something like 20 milliamps. So this would be milliamps. And to convert into amps, you just divide by 1,000. So this would be 0.02 amps. I don't have any of the problems on homework needing that conversion. One last thing. tomorrow. Most people finished it in class. So in case you're curious on the lethality, so 0.001 amps of current, you begin feeling it. Put your mask on. Mild sensation when you get down to 10 milliamps. So 0.01, a painful shock. 0.1 is death if it goes across your heart. Also, so how do your muscles work? Electricity. You think about closing your hand? What your brain is doing is sending electrical charge down a neuron, which goes and hits the muscles in your hand, causing your hand to contract. No, so it's chemicals and stuff. But anyway, my point is what would happen if so at 0.01 amps, so a hundredth of an amp, guys, pay attention. At 0.01 amps, a hundredth of an amp, if you touch a wire, the electricity is going to go into your muscles. And your muscles will contract. They're going to contract so much that your fingers are going to be cutting into your hand. You will sit there and put a death grip on the wire. Then your entire body will become paralyzed as you watch and feel your hand catch on fire. Yes? Yes. But it is an extremely painful death as you're paralyzed watching your hand spark and start catching on fire and burning. You would feel everything. The electricity, as it flows through your body, will cause other muscles to tense up. People have twitched and pulled on their back so much they broke their spine. So imagine how difficult it is to break a human bone. Your muscles will contort in such a way that you actually break your own bones. Yes. You'll be paralyzed. You might be exhaling a little bit, but usually your breath stops too. And as long as this doesn't go through your heart too much, you could be living through that entire experience, so it might not be instant death. Again, if the thing that mostly kills you is the current going through your heart, which means if someone's touching the wire and you go up and with their right hand and you go up and touch their shoulder, you can first of all go and have the electricity flow through their hand and go through their heart, and they'll instantly be dead. But the electricity is going to keep their muscles tight. So as soon as you touch them, they're dead. But now you're being electrocuted. And you're in the same situation they are. In which case, you use Hunter's thing. We actually had a 2x4 a paddle with a giant big sign hit very hard. So the you usually want to grab something that doesn't conduct electricity, such as wood, and hit the person off. If not, do not go up and push them. You can maybe go up and do a hard kick because of the rubber on your shoes, but you do not want to actually touch them. That too. But most of the time, running charge might be best, but you really want to get a stick and hit them off of a live wire. Again, if it's high enough, people have sat there and died on electrical fences, and it's extremely, from what I've heard, painful way of dying. As some people have survived long enough to describe that was the worst experience, please kill me.